This week, a major AWS outage reminded the world just how fragile the internet can be when most of it relies on just a handful of companies. And all of it traced back to a single bug in a single data center in a single region. Let's talk about what really happened, why it really matters, and what this says about the future of data sovereignty. AWS, Amazon Web Services, revealed that the outage began with a defect inside its automated DNS management system. Now, if you're not familiar, DNS is basically the phone book of the internet. It connects web addresses to the servers that actually hold your data. AWS runs on an enormous amount of DNS automation to keep everything balanced, replicated, and healthy across hundreds and thousands of DNS records. But in this case, a single empty DNS record appeared inside the US East 1 region. That's Amazon's huge data center cluster in Virginia. And the automation designed to fix it, well, it failed. It needed manual human intervention to recover. And until that happened, services relying on DynamoDB, Amazon's database system, couldn't connect properly. And if I pull Amazon's actual update in front of me, it does make for some quite interesting reading, though it is quite a lengthy update. But then again, I guess, yeah, if a third of the internet goes down, we probably want quite a lot of detail to explain what happened. Some of the more interesting points to pull out of this report are, first of all, the actual issue started around about, just before midnight, October 19th/20th, and it wasn't resolved until 2:20 p.m. PDT on October 20th. So all in all, that issue took about 14 hours to resolve. And the important thing here is that, yes, okay, for the US, they were only impacted for maybe just over half the working day. But for Europe, for any services in the UK, Europe, and anywhere else, chances are they were probably impacted for basically the full working day. So any business critical services were unavailable for a full working day as a result of this issue. The next interesting thing to read is that, yes, whilst the issue started at 11:48 and it was to do with the Amazon DynamoDB, basically that is the kind of database for the Amazon services, but the interesting thing there is it actually led to a cascading failure across a range of other services, which does make sense. If it's a DNS issue and you need to make DNS changes to resolve it, even if you're going in and manually implementing these changes, depending on what the DNS record is and what the time to live value is for those records, then that could take quite a while, even though you've made the fix, to then actually resolve the issue. So we can see here that the actual DynamoDB issue was resolved at 2:40 a.m. on October 20th. So only around about 2.5 hours after the original issue started. But then between 5:30 a.m. and 2 p.m. on October 20th, the network load balancer services then were experiencing connection errors. And thirdly, on top of that, between 2:25 and 10:36 a.m. on October 20th, new EC2 instant launches failed. And for those that don't know, EC2 is essentially one of the hosting platforms that Amazon operates. Typically, if you're running your own virtual machine, then EC2 is probably one of the services that you are making use of. And it wasn't just these services that were impacted, a whole range of services were impacted, such as Lambda, ECS, EKS, and Fargate, Amazon Connect, STS, which is the security token service, IAM and console logins, Redshift, and a lot of other dependent services as well on top of that. So essentially, we're looking at the full Amazon stack of services that were all impacted because of the reliance on DynamoDB. When AWS sneezes, the internet catches a cold. The impact of this outage was felt globally. Everything from tax services like HMRC to gaming services like Roblox and Rocket League. Even check-in services at some airports were affected. And that's only a month after ransomware issues impacted some of these airport services only a month ago. Around 2,000 major platforms were affected. Even Ring doorbells and smart home devices could not connect. For companies like 8 Sleep, the outage wasn't just inconvenient, it broke critical functionality. Their customers literally couldn't adjust their bed temperature or incline because the app couldn't connect to AWS servers. To their credit, 8 Sleep quickly rolled out an update to allow Bluetooth control, a clever fallback that highlights the bigger lesson. Redundancy matters. The fact that this outage had such a large impact really highlights the fact that we don't have a lot of redundancy anymore in our global internet infrastructure. And that's because the infrastructure that we today call the cloud is actually made up of only a few different players. You've got Amazon, Microsoft, and Google. Sure, there are other players in that space, but these three main players take up the vast majority of cloud infrastructure. So when one of them has an issue, everyone does. We've gone from having resilience to having a single point of failure on literally a planetary scale. And this brings us to an increasingly important concept: data sovereignty. Data sovereignty is the legal idea that data should be stored and managed within the country or region it belongs to, subject to local laws, protections, and governance. When your data, your website, or your business lives entirely inside an American hyperscaler like AWS, effectively, you're placing your infrastructure and your customers' privacy in someone else's hands. A regional outage across the world can affect you wherever you are globally. A policy change can change your compliance overnight. Your data could suddenly be caught in the middle. The takeaway here isn't that AWS is bad. Outages happen to literally everyone, but it is a reminder that diversity in hosting matters. When businesses use smaller regional providers or multi-cloud strategies, they protect themselves and the broader internet from centralized failure. And it's not just about uptime, it's about ownership, control, and trust. So the next time that you hear about an AWS outage, don't just think of it as a little bit of a tech hiccup. Instead, let's take it as a sign that maybe we should start thinking about how we really host our services online, and should we really be putting our eggs all in one basket.